We're going to be doing some sketching of some oblique problems, and notice the only tool I have out right now is a pencil. You're going to want to probably have some graph paper, and if you didn't buy graph paper for the class, that's fine, you don't need it. I'm going to give you a resource where you can download and print graph paper anytime you need it. So to create some of these pictorial drawings, you're going to need some graph paper. And if you don't have graph paper kicking around the house, no worries. If you've got a printer and a computer and an internet connection, that's all we need. What you can do is, if you need graph paper, printfreegraphpaper.com. Okay, and the whole point of the website is to give you access to different kinds of graph paper as you need them that you can print on the fly. So there are lots of different kinds of graph paper on this website. Pretty cool. So you tell it the kind you want, and then you tell it the size of the paper you're working on, and then are you measuring in inches or millimeters, and then which graph paper subset do you want. I set my first one up for oblique drawings. We want quad paper, which is the square Cartesian graph paper, X and Y with equal increments. 8.5 by 11, we're measuring in inches, and then you get to pick how much of a space do you want on your grid. You want half, quarter, fifth, tenth. I think for what we're doing, 1/4 inch squares is pretty good. Okay, so what you'll do is you'll click on print, and then in about a second or two, the program, the website, will develop a piece of graph paper for you. So it didn't really print it. What it did is it created a PDF file. So if you like this, you could download it, save it on your computer. And if you wanted to print it, you could print it right here from the browser. Just tell it which printer you want to use, and there's your preview and how many copies. And hit print, and away you go. Okay, and then when you're done, you can close up that window. And it's not great, it's okay. Of course it's light gray, and of course your pencil's gray, so if you don't press down very hard, you're not going to see your lines. Blue line graph paper or green line graph paper is much nicer to work on, but in a pinch this will do. On the piece of paper that I've got, the graph goes both directions, it's equal in both directions. I'm going to just hold it portrait style, so long ways up and down. I'm going to fold it in half. And then what I'll have is I'll have a top half of the paper for one oblique drawing, and bottom half of the paper for a second oblique drawing. And since we're just sketching, we don't have to worry about tools or taping things down. Okay, and this is enough space to do our sketches in. So here is our first problem. So the way to go about it, of course, is to start off by sketching the front view. So what does it look like in the front view? Okay, when we have the front view sketched, we're going to give it the illusion of depth by projecting back at 45 degrees. And if you take a square, like all of these squares on the graph paper, and you cut it in half diagonally, well, that creates a 45-degree angle. So let's do this. Let's go back, and I'm going to go back 4 squares. And I'll do the same on this corner. And I'll do the same on this corner. All right, I've gone back an equal amount on each of those 45-degree angles. And then since I have a line in the front, I will need a vertical line in the back. Since I have a horizontal line across the front, I will need a matching horizontal line in the back. And that is how we construct our oblique drawing of this simple rectangular prism. Next shape looks like this. Okay, again, what is the idea? The idea is to draw the front view using the graph and the straight lines that are already there. Right, this is just a front view. And as far as size goes, don't worry about size because we're sketching. And if we can get, proportion, more or less what we're looking for, that's adequate in a sketch. So now how we're going to turn this into an oblique? Well, we're going to take that front view, we're going to go to each corner, and we're going to go back at 45 degrees. And the next corner, and the next corner, and the next corner, and the next corner. And each of those corners, you'll see I went back 3 squares. I just go back an equal amount each time. Then we play connect the dots. Right? Anything that happened in the front, all these front edges will be mirrored along the back. So, horizontal line here goes there. Horizontal line here is copied here. Horizontal line here goes to here, and a vertical line here will go to here. All right, and there is our second oblique exercise. Third oblique exercise, same thing with our paper fold. Let's take a look at the shape. Okay, there's our front view, and then to oblique, back at 45 degrees from every corner. Okay, and then whatever happened in the front will happen in the back. So line here, go to here, line here, goes to here, vertical line here, copied back there, horizontal line, copied back here, vertical line, copied back here. Now, on none of these drawings, at any point, have we included anything like a hidden line, right? Because the whole purpose of these drawings is to make drawings that are easy to understand for people that don't have a lot of technical know-how or technical training or experience. Could you imagine, though, just between you and me, can you imagine that there is a corner back here, right? And if we went 4 boxes out here and here and here, that if you could see through the box, there would be a corner back there, wouldn't there? Yeah, there'd be a corner back here, and there would be a corner back here. Now, I don't want you to draw that because it will get hecka confusing if you start adding those lines. In fact, the box that looks like it's facing down to the left, once you start adding more lines, might be looking like it's up to the right. Maybe this here is the front face closest to us, right? So things get a little confusing when we start doing things like this, adding extra unnecessary edges. This looks like a wireframe model in CAD, but maybe just for you, since you have a little bit of an idea of what's going on, you can always think to yourself, you know, I know there's a corner back there. I'm not going to draw it, but I know it's back there. And if I needed to, I could find it, right? By bringing that corner down to here, means in the back the same thing happened. Right? By bringing this corner down to the left horizontally, well, we know back here there's a corner also along that back face. So please don't add hidden lines to your oblique drawings, but understand that there is stuff that we don't normally see. How about over here? This shape would be a square, right, if we were looking down on it? Do you understand that the other surface over here is partially covered up by this rising part here? And if you do, that's great. So again, please don't add hidden lines. This is just a little discussion point for you and I as we talk about the ins and outs of drawing things in oblique and understanding what we are drawing. Let's take a look at our next example. We're going to create the front view to the best of our ability. And since I'm using graph paper, it's much easier to go in there and put down some dark lines, knowing where they're going to start and stop. If you don't have the graph paper and you're just using white paper, this will be a little bit more of a challenge. That's okay. It can be done. just lay things out lightly, and then go back and darken at the end. So our shape looks like this from the front, but we know it has some depth. So I'm going to go back 2 squares for this one. Why 2 squares? Why not? Okay, and now here's what we're looking at. Now there's some stuff that's missing. Can you see what's missing? Okay, and maybe our little discussion about what we don't see will be helpful as we look at this one. There's some stuff that didn't get projected back at 45 degrees, right? This corner went back, this corner went back, this corner went back. This corner would go back, except we don't see it. Well, how about this corner? Shouldn't it also go back an equal amount as the rest of the part? Yeah, it should. And if we have a vertical line here, well, that means we'll have a vertical line here. And if there's a horizontal line here, then there'll be a horizontal line back there too. Okay, now, does this corner go back? Well, it does, except we don't see it, so we're not going to draw it. Right, just like this one goes back. So, again, we're interested in what can you see when you make these oblique drawings. This one is a thin piece of material, which means that not only do we see the hole in the front, but we see the back edge of the hole also. The back edge of this square cutout is also visible. Moving on to our next one. Let's take a look at the shape. So we're going to try to do our best to replicate that. Again, if we're sketching, we're not going to worry too much about size. We'll worry more about proportion. And we'll just do the best we can. Okay, so I think the front view looks something like that. And then project. 3, 3, 3, 3, 3, 3. Okay, and then what happened in the front happens in the back. Or if you want to think about it this way, it's connect the dots, right? Connect, connect, connect. Now this one's interesting. This one went vertical. The back corner, though, you can't see the vertical going up 1, 2, 3 boxes. Okay, now if you had made this skinnier, you might have. Check it out. If we only went 2 back, 1, 2. And you would have gone 1, 2 over here, and then yes, you would have gone up, and you would have seen that back corner, and then the vertical surface starting back there. So, depending on how fat you make it, your sketch results might be a little bit different from mine. I'm going to imagine now that we can probably sketch just about anything in oblique that has horizontal and vertical planes. So let's try something different. Let's take a look at this one. Now this one has an angle, right? So what do we know about angles? Well, we should know that you got to draw the front view, and it's been indicated that this angle is 30 degrees. So I know this is cheating, but I kind of want an idea of where 30 degrees is. Okay. So 30 degrees, but I won't use any other tools, and I'll even draw the line kind of crooked just so it doesn't look like I cheated too bad, right? So there's my 30 degree angle. So how do I make this oblique? Well, you know, there's really no difference between obliquing a rectangular object or rectangular prism and obliquing something with a slope. Go to the point where you're starting and go back 1, 2, 3, 4. And then go down to the corner here and go back 1, 2, 3, 4. Okay, and here's our diagonal line that makes the slope. So whatever happened in the front has to happen in the back also. Okay, connect the dots. This is what our little wedge or our little ramp would look like if we were drawing it in oblique. take a look at our next example. So we have some lines. It's a little bit different than the last one, and that's mostly because it's got a flat spot before the slope starts. But then it says it's a 45-degree angle, and you know the drill. You can go through the corners of the squares diagonally to create a 45-degree angle. There we go. Alright, so how do we oblique this guy? Nothing different. 1, 2, 3. 1, 2, 3. 1, 2, 3. Those are our 3 obliqued 45-degree lines. And then again, copy the front elements to the back. Alright, and there is our wedge, the little flat spot on top in oblique. How about this guy? Okay, so a little more complicated, but you know what? Don't let it scare you. It's really not that bad. Ooh, let's see. Alright, so that's our shape, more or less. So we've got the front view. What do we do now? Well, let's go back. I'll go back 2 and 2. And now this is going to be interesting. 1, 2 is actually back here. I can't see the very bottom of the valley here, the vertex. But I want to know where it is, because I'm going to have to connect that point to here, just like this point connects to here. And this gets connected, and then 1, 2, 1, 2, these get connected, 1, 2, 1, 2, 1, 2, and these will get connected, vertical in the front, gives you vertical in the back, and then 1, 2, so we know that there is a surface out here. It's partially, well, it's completely concealed by the rise here. So even though it's back there, we only see that little corner of it sticking out. Circles are a special pain in the neck, depending on what face they are on. So let's do this. I'm going to make a square. And just to have an idea of how deep to go, I want to make the depth at my 45 the same as the height and the width, so it is an oblique cube, okay, more or less. And I mean, that's not exact, but close enough for sketching, right? Close enough for hand grenades. So, if you were drawing circles in oblique, if they are on the front face, well, then they are going to be round. Okay, but if you're drawing them in the top face, well, now all of a sudden, weirdness happens. Right? So you can think about it like, well, where would the center be? The center would be there. You know, if I had to make a center mark, center mark would be there. So my circle would be kind of squished. Kind of a twisted and squished and weird looking ellipse up on that top surface. And then the same thing would happen over here on the side. I'd have a circle that was kind of a strange ellipse taken in the side there. So if you're drawing something that's round or cylindrical, it's probably best to put the round thing facing you. Okay, easier to sketch it that way. Let's try an element here. that is going to be this problem. In the front view, nothing new and exciting. It's very much a rectangular prism. Just a block, right? Block of wood, block of metal, block of something. And I'll go back 3. I'll go back 3 diagonals. And I'll play connect the dots. Alright, now how about the hole? The hole is in the front view here. So figure out where you want the center of your hole. Okay. And then draw the circle. Like when we were discussing sketching initially, remember it's probably easier to draw a circle if you have a frame to work inside of. Okay. So here's our hole cutting into this piece. So all good, except maybe we can see the back edge of the hole. You know, maybe there's the back edge back here or up here a little bit. So the question is, how are you going to know that? Where is the back edge? And you know, you can actually figure it out. If you went back 1, 2, 3 diagonals here, then find the center of your hole and go back 3 diagonals. 1, 2, 3 diagonals. See, it's right there. And then how big of a square did you make for the radius, the diameter of your circle? So I made mine 6 by 6. So I'm going to go back here. 2, 3. 1, 2, 3, and kind of lightly lay out another little square in the back here. That'll be the frame for my next circle. You see this little frame I made? It matches this frame up here, except it's 3 squares back on the diagonals. Okay, and then what you can do is you can make your circle in that frame. Okay, and with a little bit of tender loving care from the eraser, you're going to be able to figure out where the back edge of the hole is supposed to be. Okay, now I don't need this part because we can't see that part of the hole. The rest of the figure is covering it. But without a lot of work, you can kind of calculate and sketch out roughly what this hole looks like. Since this part is only 3 thick, that means the hole is only 3 thick also. So these are our oblique exercises, and you should have the same number of oblique exercises sketched out as we move forward.